Right, hi Love Sixth. Welcome to a quite quiet video about KC expression. Little Oscar's asleep and he's being a bit of a grouch this evening. But hopefully you can hear me alright, you can turn your volume up. We're just going to go through really simply how to work out the KC expression, which was in the last video anyway, and how to work out the units for KC. Not that the units mean that much for KC, but you are asked to work out the units for KC, and it's basically to make sure that everything cancels out in your equation. So we'll go through one of them as well. But so the top example actually is already in your sheet, and you can kind of see the result there, but I'll just go through this PCL3 going to PCL5 jobby. So you've got an equilibrium, PCL5 is formed, just 1 mole of it, PCL3 and PCL2 react together to form it. 1 mole of each, so actually this could be quite an easy KC, so let's get that purple pen back. Yeah, lovely. So basically KC is always equal to the concentration of the products to the coefficients of like stoichiometric coefficients, which here is just 1. PCL5, 5 there, doesn't look like it, but it's 5. Divided by concentration of PCL3, that's 3, times concentration of Cl2, that's Cl2. And it's as simple as that, because you've got all of your products on the top times by each other, but it's just one thing, and all of your reagents on the bottom times by each other as well. Okay, now working out KC, the units for KC is basically a matter of just thinking about what the units for these things, for the concentrations that exist in the KC expression are. So if KC equal those concentrations divided by each other, then the units for KC are just going to be the units of concentration for PCL5 on the top, mol dm dm minus 3. You want my little stylus that I found in the back of the drawer isn't very good. Divided by, well, you've got 2 concentrations on the bottom. You've got PCL3 and Cl2. So what you're going to do is you're going to divide it by the concentration of PCL3, so moles per decimeter cubed, and that's going to be times by another concentration, which is again moles per decimeter cubed. Now it's just about cancelling it down and then changing the whatever you call them, surds or whatever they are, to make it the actual units now. So 1 concentration on the top cancels with 1 on the bottom, and then you've basically got 1 over mole per decimeter cubed. So that means you've got mole to the minus 1, because it's on the bottom of the equation. So per mole, decimeters, well, on the bottom of the equation it says per decimeter cubed, so that's going to be just 1 over 1 times something to the minus 1 is going to be something on its own, so 1 over times 1 times something to the minus 3 is just going to be that thing cubed, so mole to the minus 1 dm cubed. Now that isn't very easy to visualize, but these are just units for a constant, and it's just to make sure that really it's a valid equation. They're nothing more than that, but anyway, like them for some reason. Hope that helped.